Hi everyone.
Hi, all. Thank you for joining this webinar this morning and afternoon. We're just going to give everyone a few minutes to join, so we'll be getting started in about 5 to 10 minutes. While we wait to get started, if you could please write the name of your hospital in the chat box, that would be great. And then we will get started with the webinar session.
Hello all, welcome to our panelists. Welcome to also our participants, our users for our machine. Just to make a short announcement, is that, okay, so, sorry, I'll start by introducing myself. I'm Magdalena. I'm in charge of training at Gradient Health Systems. This is our first ever webinar on the UAM machine, and this is mostly to support our users. It sort of creating a long-term support for our users. And so I'd like to mention the following hospitals who have their representatives here. And thank you so much for coming in. That is Maweni RRH. We have Musume Mission Hospital. Maweni is from Tanzania. Musume Mission Hospital is all the way from Zimbabwe. Our Lady of Good Health Hospital is from Uganda. Kabutare District Hospital from Rwanda. And then we have Zovwe Health Center, which is from Mbeya District. From the Mbeya City. Sorry for that. I'd really like to thank you for coming and setting up time apart. Please feel free to ask any questions that you have about the UAM machine. We have our panelists. We have where Dr. Sweetbat and Dr. Papicho, who are our long-term trainers and users of the UAM machine, will be taking you through the training. And also we do have Dr. Ndaba, who's also a long-term user of the UAM machine. Will also be on the side just to support the team and to take any questions. Please feel free to share any feedback. You can share it in the chat. You can raise your hand. Let us know if you need more of this, especially if it is hospital-based. We are here to support you. So yeah, I'll give it up to Dr. Sweetbat, and please welcome. Thank you all.
Thank you very much, Mahamad, for the introduction. As I was introduced, my name is Anslet Sitbet and Bear. So I'm based in Tanzania. This is our first product-based webinar, and actually the aim of this is to make sure we equip the user with the skills, and Magdalena says, if you have any questions, please don't hesitate. In the middle of presentation, just raise your hand or send a message in the chat so that we can discuss. So it's meant to be interactive as much as possible, because as we said, it's a user-based one. But make sure you can use a machine effectively. So this webinar will also be recorded and then will be available on the website. But also, if you have any question, even after this webinar, please, you can send it to the customer at guardian.org. Please, next. We will go through the following agenda. We have realized that some of the we are not using the machine effectively, and maybe partly because of the some of the features are not well understood. So we'll review some parts of the machine. We'll review, of course, we'll also do we'll try to remind each other about the checklist, but also we'll try to discuss some challenges. So, some challenges, can even send it in the chat box now so that we can to interact. And then we'll finish up with the question and answers. Next. majority of you, I know you went through the training, and most likely you have seen this slide. But just to remind you, we all know this is the workstation which was invented in Malawi, but of course manufactured in UK. It was made to overcome the barrier. We know our challenge.
Sorry to cut you short, Dr. Sweetbat.
Hello.
Hello, Dr. Sweetbat.
No.
Yeah, just to cut you short, your audio is not clear. It keeps fluctuating.
It is now, or still not?
Now it's perfect. Perfect.
Okay,
Keep it at that. Okay.
Okay. So it was made to overcome the barrier, as I said before. Here we're discussing more of the power and oxygen problems. As we know, it's a draw over, which of course with no APL, so that allow the mostly transitioning from the IPPV to the continuous. But also it has made with the most important thing, it is certified and also comes with a warrant and technical support, which I'm sure you are all witness. You have received that the support. When you have a challenge, you always call, and we are always there to support you regardless of the challenge. Next. So we will watch this video and then we will continue.
The universal anesthesia machine ensures that an adequate supply of oxygen and anesthesia is always available to meet patient demand, no matter what the environment. The UAM provides several ways to deliver oxygen, including connections for cylinder and pipeline. Most importantly, the machine produces its own oxygen, using an integrated concentrator that converts room air into 95% oxygen. Ambient air is made up of 78% nitrogen, 21% oxygen, and 1% other gases. The oxygen concentrator in the UAM removes nitrogen from room air, creating a mixture that is 95% oxygen and 5% other gases. Air is drawn into the UAM and is purified by 3 different filters. The compressed air passes into a canister filled with a powdered material called zeolite. Nitrogen sticks to the zeolite, while oxygen and other gases flow through it to a reservoir tank. The UAM produces up to 10 liters per minute of 95% oxygen. The oxygen then travels through the flow meter into the back bar and reservoir bag. The flow meter controls the amount of oxygen entering the back bar and available for the patient. The spinning bobbin shows the flow rate in liters per minute. The back bar serves 3 functions. First, the reservoir bag stores the oxygen. It holds up to 2 liters. Second, the pressure relief valve limits pressure in the back bar to 5 centimeters of water, protecting the patient from harm. Third, the air inlet valve allows room air to be drawn in whenever the supply of oxygen is less than the demand, as expressed by the patient's minute volume. We'll come back to this shortly. The low-resistance draw-over vaporizer adds volatile agent to the carrier gas passing through it. Volatile agent is added by using the selector wheel to achieve the desired percentage. We now have anesthetic gas comprising oxygen, volatile agent, and a variable amount of room air. The anesthetic gas flows from the back bar at low pressure to the breathing block and the bellows. A sensor reads the oxygen concentration of the gas passing to the patient. The reading is displayed on the oxygen monitor screen. As the gas flows from the oxygen sensor, it passes the first one-way valve, then the bellows chamber, followed by the second one-way valve. During spontaneous breathing, both non-return valves open for inspiration and close during expiration. The bellows are used for intermittent positive pressure ventilation, also known as IPPV, or controlled ventilation. When the bellows are raised, gas flows through the first non-return valve into the bellows. The second non-return valve remains closed. As the bellows are pushed down, the gas flows out through the second non-return valve into the inspiratory limb. The first non-return valve is closed. Another pressure relief valve ensures that excessive manual force on the bellows cannot cause harm to the patient. The UAM uses a conventional Y-piece patient connection. The anesthetic gas flows to the patient through the Y-piece, connected to a face mask, endotracheal tube, or LMA. The expiratory limb of the Y-piece channels gas to an inflating valve on the UAM that functions like an AMBU valve. It uses a balloon made from long-lasting silicone, which closes during inspiration to direct gas into the lungs. During expiration, the balloon empties and opens the exit port, allowing exhaled breath to flow out through a final one-way valve to a scavenging device. The UAM always produces the correct supply of anesthetic gas for the patient, in any environment where surgery is performed.
Thanks. So I think for the video that summarizes how the machine works. So we'll go through some of the advantages. I think so it's from the video. The machine makes its own oxygen. So basically, you don't need oxygen supply. But of course, I will see later. You always need at least a cylinder for the backup in case something happens. But in normal circumstances, we advise you to continue using the concentrator. Yes, of course, it can work without power, and this, of course, when there's no power, the concentrator will not be functioning. That's why we advise you to have the concentrator, the cylinder, but at least you will still continue with the surgery because the vent will still working because it has battery. The monitor will still work because it has battery, but also oxygen monitor will also continue working because it has also battery. So the patient monitoring is also part of the machine. Come with the patient monitor. Of course, the cost it's cost effectiveness because remember, when you're using a concentrator, at least you are not buying the cylinders like like when you're using only on the cylinders. For example, those there are some of those they are like 100 or 200 kilometers away from the oxygen plant. So you can imagine the logistic getting the oxygen and all of those. You are avoiding them with having the UAM and all of this. They are also added in the advantage, whereby you are saving your cost. Of course, they reduce cancellation and the referrals. Remember, with the machine, the way it's made simple to use. With the suspension, it can be placed even in the remote area. So having having the machine in the remote area where we can operate, because referral will be reduced. Because the most important thing, as what we are doing here, we always provide training, but also technical support. can you please we'll pause for like 2 minutes and then can write in the chat box, or you can unmute yourself and tell me what is the most likely answer, and then we can discuss. Then we'll continue with the discussion. I'll be reading in the. Anyone want to try? So we have oxygen concentrator. Okay, yes. Anyone else want to try? Anyone want to unmute and maybe you can explain? Okay, let's continue, then we'll see the answers as the moving. So thank you very much for those who have no one raising the question. Joseph Fatim Semwa says it's a UAM oxygen concentrator. Ndizeyes oxygen concentrator. Nkurunziza Richard. Okay. So concentrator, cylinder and pipeline. Next. So all of you guys who answered in the chat box, basically yes, you have got it correct. So actually the UAM you can use it with actually it has, you can use 5 sources of oxygen. So as I said before, the main source of oxygen is the concentrate, and actually that should be your main source of oxygen when using this machine. Of course, there's a draw over where you can draw in air, and then remember that's providing you with only 7%. But also there's the option for cylinder, the pin index ones. But also there's the option for pipeline. And most of those, I understand, we don't have the plant, so that we don't have the pipeline. So when we are using the big cylinders, this is where we always connect. The last option is where actually it's for emergency. In the event you have the challenge of a patient and then at the source of oxygen, they are not supplying enough, that's where you use the emergency one. Remember, when you connect the oxygen this one, even the machine will provide the alarm indicating that you have an emergency. So UAM has got five source of oxygen, and all of this can be used for when using the machine. But the main one should be your concentrator. But in the event where maybe in the power has gone off, you don't have power where you cannot use the concentrator. That's why we advise you to go with the other source. Next. So I'm sure most of these are some of the represented here of the UAM, and we have seen some of the challenges, which basically some are from maintenance, but some of the sites they have challenges with the machine check. Some they have a challenge on using the UAMV, basically, so ventilating patient mechanically with the vent. But also we have seen some also with the challenge with the oxygen analyzer, and there's some of not even challenged by the vaccine cannot interpret some alarms, actually handling them, or clearing them so that they can use the machine. So these are some of the challenges we have seen so far, and we'll discuss most of this, and then we'll at least when we go home today, you know how to at least to handle some of them. Next. So like any other machine, there should be a routine care and maintenance. Because remember, for the machine to function well and to maintain that functionality and make sure it is working properly and actually making sure it lives longer, it needs to be properly maintained and do this now and then. That's why I know there are PMs, which are scheduled ones, but also when something is broken, should be taken care immediately so that the machine can be used effectively. But also, you should avoid, you know, there are some we have seen some of the parts which are actually, of course, as I told you before, I'm another system anthropologist too, and there are some parts actually they break down because of our own challenges, or sometimes we even do misplace some of the most delicate or most important part of the machine to the point that using the machine becomes difficult. So, like the way we always make sure the theater is well equipped. The way we make sure everything is well organized. Even the machine maintenance, actually making sure the machine is very functioning is us, is the provider's responsibility. Because when the machine is full functioning, that's why we provide safe and good care to your patient. So you have to make sure that the machine is well maintained. And actually, this is our responsibility because it's like you having a car. So if you want to maintain your car and the brake are not working, you know what will happen. So it's the same with the UAM and the other machine in theater. But even if it's the afternoon, and you have to make sure it's well functioning, so that you can use it properly. And the half-life of the machine, of course, we say 5-10 years, okay. But we all know if you maintain the machine properly, and it will always last longer, and actually it will give an anesthesia to many patients, and that is how you will also enjoy it. Next.
Hello, Dr. Sweetpet.
Hello.
Okay, yeah. So I just wanted to make a quick contribution on this current slide on the issue of general machine care, as well as maintenance, how we take care of our machines and other equipment. My name is Dr. Ndaba. I'm from Zambia. So I think in most settings, or most of us generally don't do so well when it comes to taking care of the machines. I remember there was a time when we went through, we're collecting data from some of the facilities that had the UAM. So, and other machines also. I think one of the things that we just noticed was how well the machines were being taken care of, just in terms of general cleanliness, order, and how the different components are kept. I noticed that, generally the majority of us don't do so well, and sometimes we want to delegate it to maybe the porters or theater assistants to organize the machines for us. But you see, sometimes the other theater people may not know the importance and the value of the machines the way we do ourselves. So just to write down your comments, I think this is very important, because if you don't pay attention to little details, small delicate components of the machine, that will affect how long the machine will remain serviceable or remain functional. I think the emphasis again is to start with little things like just making sure the machine is clean, it's well organized, all the components are well packaged, but sometimes you'll find the monitor cables and lines, maybe they are dangling on the floor. The breathing circuit is all over the place, the flow sensor, things like that. You easily lead to damaging of the machines, and it will affect, the overall provision of anesthesia. So I thought I just mention that also from my own experience and also observation from colleagues. Thank you, Dr. Sweetpet. I submit.
Thank you very much, Ndaba. Yes, for such a good contribution. And of course, we all in theater, and theater has got so many people, and everyone has got his responsibility. But taking care of the equipment is 100% our responsibility, because actually it goes the way to the patient safety. So that's why you should always make sure they are well equipped, and they do function 100%. Next. Okay. Part of the maintenance, and actually this is to be done routine before starting the day, but also there are some checks which we do between the cases. Because actually the aim, apart from you understanding the machine's work, it's full functioning, but actually it's a good practice for patient safety. That's why we advise to do the pre-use machine check every in the morning, but also there are some checks between the cases. So machine check is actually standard and actually linked to the patient safety, but also it helps you to identify the challenge with the machine, and then from that you make decision. But there are some problems why you might not think. For example, if you are checking the machine is leaking, there's no way to give anesthesia. There are some little bit issues where you can compromise and continue working, as long as they want they are not endangering the patient. But as I said before, machine check, fuse check, it's actually it's a maintenance thing, but so that it improve lifespan. Poor compliance to the check, and actually it's like you muting your phone while you are on call. Of course, you by the time you watch your phone, you'll find there are 7 missed call, and you are missed so many cases which could have been operated. So not doing a machine check, actually you are skipping, you are silencing the problems, which are eventually will be there and they'll be accumulating themselves. So I think, and we advocate for you to do the machine check every morning, and also and between the cases. Next. So every machine has got this the laminated page, which actually I won't go through all of them, but these are the area you check. So you check for the UAM, check for the UMV, you check for the oxygen monitor, and you check for the power and all of those. So on the UAM, you check for stability, cleaning, electrical grounded, availability of the compressed gas. Remember, compressed gas is a backup. It's for emergency. That's why all I advise to have at least one. I've gone to so many places where actually there are so few of them, which they always keep the backup compressed gas. But we advise it, and that's why you have to check and make sure not only you have a cylinder, but also you should check if it has oxygen. You have to check for the UMV bellow, you check for the Zeverberg level for volatile agent, but also make sure the selector wheel is working. You check for the selector switch if it's still working. Of course, you confirm you check also for you confirm if the circuits were assembly and were connected, but also make sure there's no leak. You check for the phantom balloon, and also pressure relief, where we all know that when you block the UAM circuit and then when you beg, it should open at 55 centimeters of water. And then we also make sure you check that and make sure it's properly connected on the machine. You check for the scavenging system. Next. You check for electrical, as I said before, and then you check for oxygen analyzer, whereby you just turn it on and also calibrate oxygen. We will go through this later. And also you check for the concentrator, whereby you switch it on, you leave it on, and you make sure it's run and see how much oxygen to regenerate. And once that's done, you go for UAMV, and also we'll go through much different later. Maybe I can ask just a question for 1 minute. How many of us do machine check every day in the morning? And how many of us do machine check maybe once a week? And how many of us we do machine check maybe once a month? Just be honest, just an honest discussion. But that's why we want to see. Basically, I actually want to know what if you have any challenge and why you're not doing it every day. So you can just write in the chat box. How often do you do it? I'll post 1 minute and see, and I'll read some answers. Those who does it every day, please you can tell us. Those who does it once a week, please also tell us. And of course, you can share your experience. Why are you doing on that schedule? Or you can raise your hand and then share your experience. That's also allowed.
Just to add, Dr. Hello, Dr. Sweetbet. I think just to add another question that do do we have any challenges, or what part of machine check do we have challenges for the UAM? Are there any specific areas where there are challenges when you're doing machine check for the UAM? What is your experience with machine check? Please feel free to unmute and make a contribution. Thank you, Dr. Sweetbed.
Thank you, Ndaba. Let's give 2 minutes, then we'll continue. Moy Amin, can you please share your experience? Moy Amin, Dr. Allen Katsande, can you please unmute yourself and share experience? Moy. Nkurunziza Richard. Okay. Let's continue, then maybe we can discuss later. So actually, basically, for the machine check, okay.
I think we have someone who wants to participate. I just unmuted.
Please go ahead. Mariam, who wanted to go? It looks like Allen is in the noise.
Richard has his hand up.
Unmute, go ahead. Nkurunziza, Richard. Richard, unmute yourself.
Oh, thank you so much. Actually, shortly my earbuds are going off. Maybe let me a bit charged, then I can come back and I give my submission shortly.
Okay.
Okay, thank you.
Yes, thank you very much. We'll continue as we said. Okay, now, Mariam, next. We all know that when providing anesthesia, oxygen is one of the most important gases we use, and actually should be monitored. So the machine comes with the capacity of monitoring the fraction of oxygen, but also this has a battery which can last even 10 hours where there's no power. So even during the power challenges, you can still use the machine and you can still monitor the oxygen. If oxygen fraction, how much you are giving. But also it has alarm where you can set the high up and the lower can alarm when you go beyond the limit. So should be calibrated basically on daily basis, but If you have 100% oxygen, yes, you can calibrate the air and oxygen. But if you don't have 100% oxygen, we advise you to calibrate with only air, as you will see it later. Next. So this is the display. It has mode. It has calibration setting. It it shows you, it displays the percent of oxygen, but also shows the alarm, the higher and the lower lower level, which basically it will alarm when you go behind this limit. Since I think all of you know this, so I won't spend much time on here. Next. So the most important thing is calibration. And as I said before, calibration is very simple. You go to the car, you go to the hair, and then you go, once it calibrates, you just go twice, and then it will come back. You just calibrate car, air, and then you go. Once it's done, you will exit, and then it will be calibrated. So when you have 100% oxygen, yes, you can even calibrate the oxygen. But as I said, and I think I would advise you guys, if you don't have 100% oxygen, don't calibrate it, because when you calibrate it with the oxygen percentage, which is not 100%, in the event the machine produces higher oxygen percentage more than what you have calibrated with, the machine will display more than 100, maybe 104. And basically, it doesn't mean that you have oxygen more than 100 in the system. It means the difference you gave the machine was lower than what actually is being produced now with the concept. So we really advise, if you don't have oxygen, if you don't have 100% oxygen, please only do the air calibration. So the procedure is the same, simple. You make sure that you beg. If you have used the machine with oxygen, or when you switch on and found it maybe 65, you beg until it's you beg to the lowest level, which most of course it will be 20%. That's where you calibrate. And while begging, make sure oxygen is closed. So you beg, make sure it's only air coming in, while the oxygen flow is closed. And then once you attain the lower percentage, that's where, of course, which will be most likely within 1. And then you calibrate, as they say, car, air, go, and then you will exit. Next. So the machine comes with a vent. You not on, so you like any. Hello.
Before you go further, can I make my personal comment on my experience on what I do on calibration?
Karibu, welcome.
Asante. So my name is Dr. Papichok, speaking from Livingstone in Zambia. With our UAM, we also do have oxygen. Our oxygen that we get oxygen from the cylinder. Okay, as you know, UAM, the main source of oxygen is the oxygen concentrator. So we use oxygen concentrator as the main source, but for backup, we use the cylinder. Sometimes we have challenges with power, so we go back to the cylinders. So the challenge that we have is that we don't have one source of oxygen cylinders. We have different people or different companies that bring the oxygen to us. So you find that they come at different concentration. And that gives us a challenge when calibrating the oxygen analyzer with the cylinders. So we've agreed to avoid such problem of adding readings that goes beyond 100. It's better we calibrate our machine using the room air. At least we are sure that the room air, wherever you go, the percentage of oxygen should be the same. So that's our own experience that we do. Yeah. Thank you.
Thank you, Papicho, for sharing your experience. Okay, so the machine also comes with a UMV, so that we know. Sometimes we have long cases where you have to cannot bake for 3-4 hours, so you have to use the machine. Of course, my experience is using the event because with the event you know how much we're providing. If you start the volume, you know exactly I'm giving you whatever the patient wants. So I always prefer to use the event, and most of the time when I'm giving TA. So the machine comes with the vent, so that to allow you to give your anesthesia comfortably. So most of the place where UAM is, there's no critical care, there's no ventilator, so there's a little bit challenge on mechanical ventilation. So that's also reflected when using the UMV. But our training, during our training also, this is the part of the area where we always emphasize and make sure we equip our users with at least enough knowledge to use the machine, because we know it's one of the key feature of the machine. So with experience has shown there are some few challenges, which mainly we have flow sensor calibration. And actually, on the flow sensor calibration, they actually this comes in 2 ways. Some calibration actually really calibration of it, but some of the user, when you tell them do the machine check, they go straight to the flow calibration. So flow calibration actually is a part of the machine check. It's not the machine check. So I've been in some places where every time you discuss with them, you say, no, let's go through the machine and do machine check. People go straight to the calibration. So this is important to be done, but should be done as a part of the machine check. Not only you do the flow cal and then it's passed and then you assume the machine is okay. But also our challenge we have been encountered. It's a parameter setting, and actually it's even worse when it comes to pressure. You know, you see that the machine has got volume, pressure controls, and continuous. The challenge, of course, they are challenging in using the ventilator, but the main challenge is when someone wants to use the pressure control. So also we have seen that, but also some alarms, which actually this goes with setting the limits, but also setting exactly what you want. It has been a challenge in most of the place. Of course, interpretation of the because remember they are parameter set, but they are measured ones. Yeah. So most of us we have some difficulty in interpreting to interpret what the machine is telling us. Of course, we understand that the challenge of mechanical ventilation is challenge to everyone. But we know in our training we always emphasize. That's why when we pick, we know that this site maybe they have that experience. I have some users which actually I had to advise them. You start with the volume control, because with the volume control you just go in, set your limit, set your tide volume, set your rate, then you are okay. So these are some of the challenge we have picked, and then we actually, if you have encountered the end of this, maybe later on during discussion we can discuss more and come up with a way forward. Next. So these are 2 and 4 questions. Let's pause for like 1 minute again, and then we will read some answers. But if you are somewhere where you can talk, please unmute yourself, and then you can answer, and then you can discuss. So this forum is meant for discussion, so that we can share experience, and then we can make sure we clarify some of the issues. Who is ready to go? Hello? No one is typing. Okay. You Lugange, Yaya, can you try? Maybe Rajabu Mtuli. Unmute yourself. Next, we'll come back to the question we're doing discussion. So, UAM overview. So as I said before, the machine does pressure control, volume control, and spontaneous, but also can ventilate. It has a wide range of tidal volume, so that can be from the pediatric all the way to the adult. But also that goes all the way from tidal volume, the total rate. You can use it to actually from the pediatric cases, maybe starting with 10 kg and all the way to whatever other patient you operate. But also it has spontaneous mode, but most of us, I understand, we don't use it. But of course, if you have skills using it, but of course also you can use it. It accepts fixed variable PIP, but also remember this is mechanically driven, so you don't need, so there are some vents where you need a pressurized gas so that it can run a vent in multiple ones. So this one is actually it's actually mechanical ventilated, and the vent can be used up to 6 hours when it is full charged, and we advise always make sure the machine is always on power and the green light is on, and also all of this be connected from the machine. So that make sure they are all charged. So even when the power goes off, there should be full charge, so you can use to the full capacity. Next. So looking at the part of the machine, and this is really important because that in case, of course, for you to use the machine to provide your anesthesia, but also they are also good for communication. When you are communicating, maybe you have a challenge, you can speak the same language. So there's a bellow, which we know it as there as the blue one. It has a arrow, which is for measurement, whereby it actually display the lead time measurement of the machine, minute volume, tidal volume, peak pressure, mean pressure, and PIP. They all be displayed there. But also there's a column for the setting, which actually this display all parameter which you are setting for your patient. They have ventilation mode, which volume control, pressure control, and spontaneous, which are displayed there at the bottom. But also there's a display for waves, which actually shows the real time, which can be used for monitoring of the patient, or depend on what you are using to ventilate, but also what is displayed. Then you can interpret according to your patient. So always make sure you are familiar with this part and what is where, because in the event you have challenge, you have to communicate, or what I will ask you, go to the mode, go where. So it could be easier for communication, but also for you, for taking care of our patients. Next. So the vent work when you isolate the barrel. Yeah. So the most of the time, and you have to be very careful with the barrel isolator switch, because in the training, we always teach people that when you want to use the vent, you change it. You have to change the isolator switch, and then you go to the vent. You set your parameter, and you are coming out. You stop the ventilation, the mechanical ventilation. Then you go to the barrel isolator switch, that you can continue with the barrel ventilation. But in the event you start your mechanical ventilation, and the barrel isolator switch is not on the mechanical, on the vent, the air will be coming in the barrel, and that's where alarm starts, and that's where everyone panics. So this is the most important. This is the most important part of the machine, especially when you want to use the vent. But always make sure you operate it the way I have just explained. Next. But also another important thing is connection. How the vent is connected, how the flow sensor is connected, but also make sure how the driver hose is connected on the vent, but also on the machine, and how the flow sensor are connected, and not only connected, but how is oriented on the breathing circuit. This is really important, and make sure the connection is in the correct order, but also the alignment of the flow sensor should also be correct. As it says, always the blue one should be proximal to the patient. As it's shown on the picture, you see the black drive, the black tube, which the vent drive hose comes from the back of the vent all the way to the side of the machine. Next. So this is to emphasize what I just said. Always make sure the flow sensor is correctly oriented on the breathing circuit, because otherwise it's giving you errors, and you might not enjoy your machine. Next. Okay, so when switching on, the most important things we are selecting, if you have to select a patient, so there are two options. Either you go with the preserved ones, which actually this were done by weight, where you just pick the weight, and then the machine will display some of them as it's shown on the other side, on the left side. For example, now they just picked the 50 kg, and these are some settings which have been displayed. Tidal volume is 400, rate is 12, E ratio is there, and then the limit even shown, everything is displayed. The other way is you can do you can have the user ones whereby you are the user, you save them in the machine. As you see there, the user one can have, depending on your name, maybe Amis one, Richard two, whatever, and then so when you come in, you just pick whatever you want, then that will take you to the machine and continue with the machine. Next. So this is how it looks like. As I said before, on the left side, the user setting. On the top one, these are the measured one. So always when you use the machine, always compare. Even if an alarm comes on, before you panic, before you change anything, always compare what you have set against what is being measured. Once you know, for example, let me say, if I set the volume 400, and then the machine gives maybe 200, and maybe there's another alarm, that will give me a clue. Maybe there's a leakage somewhere. So always, instead of you just jumping to the alarm, and then instead looking to try to panic. So always compare the setting ones and the measured ones, and from there, that will give you a clue what should be looked at next. Next. So, like on the oxygen, this also needs to be calibrated, which always you disconnect the drive hose, you connect the radio adapter, you orient the flow sensor as it's shown. You go for the calibration, where you just go for the car, then calibrate the flow sensor. Once it's done, it will always tell you to reverse, and then once it's complete, it will display. So this we advise to be done at least on the weekly basis. We will see on the video very soon. At least this we understand we are busy. Sometimes we are being called with the emergency, but try as much as possible. At least do this at least once a week, no matter how busy you are. Next, I think we will watch a video, and then we will come back for discussion.
The ventilator's flow sensor is a critical and delicate component of the ventilator. It is used to make all the breath measurements. This includes inspiratory and expiratory flows, airway pressures, and tidal volume. The patient flow sensor requires calibration when being used for the first time, periodically every few weeks, if damage is suspected, after cleaning, and if the set volumes and pressures differ from the measurements displayed on the screen. These are the items you will need. Red calibration connector. Calibration procedure. Disconnect the ventilator drive hose from the ventilator and attach the red plastic adapter to the 17mm bellows driver taper on the rear of the ventilator bellows assembly. Connect the patient flow sensor with the flow in the patient direction. Blue line closest to the patient, clear line closest to the ventilator, to first calibrate in the forward direction. Press the Flow Cal button. Press Calibrate Patient Flow. Press Yes to start calibration of the inspired flow. When prompted, turn the flow sensor around to calibrate the expired flow and press the Continue button. Note: the ventilator will prompt you to put the sensor in the correct orientation if it is connected incorrectly. When complete, press Exit. If the calibration fails, perform the procedure again from the beginning. If it fails again, you must perform a pressure transducer zero offset calibration, followed by the flow sensor calibration. If it fails again, replace the flow sensor with a new one. If a new sensor fails the calibration, please contact Gradian for service. After calibration, reconnect the flow sensor to the patient circuit Y piece and place a clean patient bacteria filter ready for the next case. Reconnect the ventilator drive hose between the bellows 17mm taper and the UAM anesthesia machine ventilator connector.
So maybe I can also ask another question. How many of us we perform that procedure on our daily basis, or maybe weekly as it says? Okay. If you have the answer, please you can share in the chat box. Next.
Yeah. Hello, Sweetbet.
Nam karibu.
Yes, Doc. Yeah, so I just wanted to share some experience as well on this very important aspect of a machine check, the flow sensor calibration. I think it's also another area where we frequently get reports about the ventilator not working, always alarming and making noise. So the flow sensor calibration, it's key to the function and operation of the UAMV. If the flow sensor is not calibrated or it's malfunctions, it means your vent will not function properly. It will either be alarming or it will be giving errors. So the flow sensor calibration is a very, very important aspect of the vent. Yeah, more often than not, I've received calls for people saying, no, the vent is not working. It keeps making noise, it keeps alarming. And then we go through the flow sensor calibration together. They check, make all the connections nicely, and you find that the vent stops alarming and it starts working properly. So just to emphasize again, I think it should not be underrated or underestimated. It's a very important aspect of machine check as well as the operations of the ventilator, because from the flow sensor you get those measured parameters, and then if there are any abnormalities in the flow, in the pressure that is being measured across the flow sensor, or in the differences in the tidal volume, it will give you an alarm for you to be able to sense that maybe there's a circuit disconnect, or patient is there's high pressure, alarm, and so you'll be able to know and you'll be able to act accordingly. So it's a very important component of machine check, and it should be done routinely. I think weekly, like Dr. Sweetbet mentioned, is sufficient. But the key message here is that it's something that should be done, and done regularly. And also we need to take care of that component so that it doesn't break, because once it breaks, it means you lose the ventilator function. Your UMV will not work properly. Or if it's not connected properly, it reversed, your UMV will not work properly. Or it's missing in the circuit, then your UMV will not work properly. So it's a very important component of the UMV. Thank you, Dr. Sweetbet. I thought I'd share that. Thank you.
Thank you very much, Ndaba. Next. So this is to remind ourselves on the capacity of the vent. I think all of you guys went through this during the training, but just to remind you, the machine can do the volume control, where we know when the volume control, just set the volume, the machine will discard the place. That's why I have to make sure you set the light one according to the weight, or of course the age is also considered. But I think you all know the range of the tidal volume. And actually, we do advise you, of course, you go to the lower side, yeah. You know the range comes from 5 to 10, but I think using 7, 6 is always okay. If you know, if you have a good experience, can go with the volume control, whereby you set your target pressure with the pressure control, whereby you set you set your pressure targeting a certain amount of air to be taken in. So the bad thing with the pressure control, you have to be more aggressive in actually monitoring, because any smaller change with the compliance will always change your tidal volume. But also, if you have that experience, it's fine too. But also, the machine can be used for spontaneous breathing, whereby you just put on spontaneous breathing, you provide your ventilation, but the machine will help you. In monitoring and actually plotting some graphs for you. Next. So as you see down there, these are the modes. So you have to, if you want to change, the most important thing, you can change whatever you want, but you have to confirm once you select the mode the mode you want. But I'll be honest, I'll still advise, if your experience is not as good as those who are in the referral hospital, wherever, you can also start with the volume control, and you will always use you provide anesthesia for your patient safely. Because remember, in anesthesia, always do what you are comfortable with. Otherwise, as Ndaba says, or as we just said, if alarm comes, when the machine is confused and you are confused, no one will help each other. No one will be there to help one another. So always make sure, if you know how to do the pressure control effectively, yes, you can go. But otherwise, I advise those who has got experience, like the majority of us, just volume control should be okay. But when you want to change, just go change and then put the desired one. And the most important thing, you have to confirm. Next. Yeah, so the machine comes in with the alarm. So we know alarms are made to protect the patient. Alarm should not be silenced. Alarm should be attended. So when there's no alarm, that's how the machine will look like on the left side. Where there's alarm, that's how it will look like. So there'll be on the area where there's a challenge, it will be red in color, but also there'll be a message on the machine telling you what is happening. So there are some alarm will be displayed depending on the value you have set. Here you have low tidal volume, high tidal volume, low maintenance, and high minute ventilation. But also there are some which are automatic in the vent. Here we have apnea, high pressure, low battery, and battery discount. Please attend alarm. Do not mute alarm, because remember, alarm, they are like pain, you know. When you go somewhere and you feel pain, if you touch something and it's hot, pain, it's meant to protect you. So the alarm, that's the same. When you have you see the alarm, before you mute it, attend it and make sure it does not harm the patient. Next. So the machine comes with a back bar. Actually, back bar attach the barrel, and basically it also have a pressure relief limit, as we saw in the video when we played in the when we started this webinar. But also this is the area where the machine will draw air in when you need to add some air on top of the oxygen your oxygen you are providing. So then also the machine is attached. Here is where the reservoir bag is attached. The reservoir bag is meant for reserving oxygen, so that the machine can draw oxygen from here when giving the patient. But also this can help you in monitoring the patient. When your minute ventilation matches the flash gas flow, this should be half filled or half empty. The moment this is collapsed, you should know the minute ventilation is higher than the flash gas flow. That's why the machine, that means the oxygen, which is the oxygen you are providing, is less than what you are targeting. And of course, by then the machine will draw air in. But also same thing, when oxygen is too much, comparing to the minute ventilation, this bag will be will distend. So when using your machine, make sure this is half filled or half empty or half full. Next. Also, it has a vaporizer. We all know it. I will speak just two things. Number one, always make sure the selector wheel is working. So as a part of the check, we saw always you have to place and open it, close it. You don't need a key. You can fill allothen or any reactor agent by opening that. But always remember to empty the arrows, the vaporize now and then, so that you can discard the. Of course, you have to use it all the way. Maybe when it's almost down near the empty line, that's why you can drain it, so that you can remove thymo. These are depend on how busy you are, but this will be done at least maybe every month, or some sites they're not busy, can go up to 2 to 3 months, but we advise monthly. Next. So the machine comes with a monitor, as I said before. Actually, the monitor helps you to provide safe anesthesia. It measure ECG, temperature, NIBP, and also pulse oximeter. Yeah. On the ECG, it can provide 7 ECG waveform, so which means it just give you a wide range of monitoring, but also it's a 5 channel, but also it analyzes the arrhythmias, so it just give you a clue what is happening. But it can be done, can be used for adult, pediatric, or neonate. The most important thing also, this can be used even if the power is off. The battery can last up to 4 hours when it is full charged. I think we went through this during the things, and nothing is new. Maybe next. The most important is also alarm. The machine comes with alarm, and actually they have been assigned the different priorities. There's the high, low, medium, and none. So when the high alarm comes in to the flash LED, on the medium one it will be orange, but on the low ones it just be an solid orange light on the machine. So as I said before, when alarm comes, before you ignore it, please attend the alarm. Next. One minute for this question, then we continue. When? What are the important things? Anyone want to try? Okay. Okay, we'll come back in a few minutes. We're almost done. We come to discussion. So the scenario here. So okay. So you have someone replied in the group, in the chat. All should be checked importantly. Okay, thank you very much. And Zay, I quite agree. Everything should be checked. So to open up the discussion, here we have a case where I will read and then we will discuss together. So you are anesthetist on duty at your facility over the weekend. You are covering the emergency theater and staffing available is reduced. You receive a first call of the day that there's a booked case of ruptured ectopic pregnancy. You are urgently needed in the theater to end of the case. You arrive and quickly review the patient who is already at the theater door step. You realize that patient is in shock and you don't have time to waste. The routine nursing preparation takes place and you induce your patient for general anesthesia. After intubation, you realize that the machine does not deliver stated volume. Next. So, what is your comment on preparation taken by the anesthetist? Anyone, please, you can unmute and then you can discuss.
Yes, hello, doctor.
Okay, welcome.
Yes, thank you for the presentation, and it is really a nice discussion. I'm sorry my voice is not good. I hope I'll be heard very well. Like you have read the scenario, though this is an emergency, we should try to do some of these simple and quick checkups to our machines, so that we avoid these some of the errors may claim the life of our patient. We're supposed to check the machine, quick checking, and so that he can rule out some of these, like in this case where the set tide volume was not being delivered, he would have checked for it in a quick way, and then he could have ruled it out before he induced the patient. Thank you so much.
Yes, thank you very much. Yes, I can't agree with you. Despite no matter how advanced it was, you have to do something because that's in danger of the patient. Who else want to add an addition? Want to go? Any comment from Dara Papicho?
Yeah, Kaka, maybe let me just come in before Papicho also makes a comment. I think, like the previous speaker mentioned, I think it brings us back to the importance of making sure that the machine is checked as part of the preparatory process before you start any case. Because they say, failing to prepare is preparing to fail. And most of the critical incidences actually happen as a result of failure to prepare. And for the machines, you have to check. I think that's a rule of thumb, that you need to make sure that the machine is checked and checked thoroughly once it passes. And that's when you can begin attending to the patient and prepare to anesthetize. For me, I think the biggest lesson is preparation. That includes a thorough machine check. I submit.
Papicho?
Thank you very much, Gilbert. I think the first speaker summarized it so well by saying it's always important to take time to check machine, no matter how emergent is the case, because this colleague of ours who did not do any check, he rushed to push in the patient, thinking that he was doing the right thing. At the end of the day, he was putting life of the patient in danger because he was giving low tidal volume, which will lead the patient to be in hypoxia. So it's always good. The first thing when you arrive, before you do anything else, you touch on your machine, you do a quick check, the most important thing, and then you bring it up to see the machine is now ready for you. Okay. It could have been that maybe the power is not there, and then you give your patient muscle relaxation, and then you find that the machine is not working. Or maybe the people worked overnight, they never charge the batteries. As you know, these machines have got batteries, but when they are not charged, they are not connected for a long period, they will go flat and then they can lead you into issues. Could have been also like simple things, maybe to check for tube connection. Maybe one tube was leaking, one tube was not connected properly. That could have led to all these problems. So as it was said earlier on by the two previous to say, always nice to do a short check, a quick check, even though we are dealing with an emergency, to avoid such challenges. Thank you.
Yeah. That takes us to the second question. What do you think could be the problem? Dear participants, dear participants, colleagues, what could be the reason for Hello. Maybe my picture, you can help. Of course, the last one we have been answered. We have said machine check will be done almost every
So the problem here, we think we have it could be different from different origins. Maybe it was a disconnection on one of the tubings in the circuit when you give, and then there's a leakage, and that leakage can lead to challenge. Or maybe it did not have enough, or maybe the concentrator was not working properly. It did not pick it up. It was not giving it enough flow to reach the tidal volume phase. Or maybe the orientation of the sensors, the flow sensor was not in the correct manner. Somebody could have passed there earlier on, cleaning the tubings, and then they put them in the wrong way. All those challenges could be reasons on why it did not set up. It could not reach the set tidal volume. That is why we said a quick machine check can really save you from such challenges, and then you have a better time to provide your anesthesia than going through such challenges. Such stress can be avoided by a simple, rapid, or quick machine check. Thank you, Kaka.
Thank you very much. Next. So these are the some of the most asked questions. Of course, for the one on the zero offset, it has been answered in the video we played. And I think that was very clear. And regarding the consumable, of course, this we also want to hear your experience. I know there's someone from Zambia, there's someone from Tanzania. We want to hear from you if you even know where can you get consumable in case you need it. So is there anyone who have encountered a challenge and need the part of the machine? Can he or she share experience? How was it? You got it? Did you get it on time? Or do you know where to find anything you want regarding your machine? We'd love to hear from you. Maybe Ndaba can share Zambia experience. No, can we find the
Come again, Dr. Sweetpet. I think I missed your your question. My network blinked a little bit.
Yeah. We are trying to advise. You know, we have colleagues from different parts of the.
Yes.
Oh yes, you have Zambia, Tanzania. So if you can share your experience, or if they have a challenge with the consumer, but where can they find it? Who can they contact?
Yeah, I think let me speak on the Zambian, the Zambian experience or perspective. I think we know that Gradient does work with a local distributor for the machines and also for servicing and maintenance of equipment within each country where the machines are. So like in Zambia, we specifically for the UAM consumables or parts, normally requisitions go through a Gradient distributor. In this case, we have a company called Atemis. Those are the first contacts for any need for the parts or other consumables. And indeed, there are other consumables that are general, that are not only specific to the UAM, but they are for general purpose use. Those ones, I think there are so many companies within each country that do supply some of the consumables or other disposable items that we use in the machines, like the face masks, sometimes the breathing circuits. Some of them are actually compatible with those that you find on the UAM. So I think the Gradient has created a system which makes it easier to actually look for these items and be able to be assisted whenever need arises. Yeah, I submit, Dr. Sweetbet.
Thank you very much. So another one is out for Tanzania. Yes, Tanzania, as Baba explained, they are someone linked to the Gradient. For Tanzania, we use cosmetics, and of course, also if you have a challenge in Tanzania, you can always contact us. You have a good number of teams here. There's Sweetbet, there's Ndai, there's Ibla, there's Teged, there's Zakaria. So so you can go through cosmetics, or you can always contact us, and then we'll take you to the proper channel. So we understand the machine has got ABS, so that to protect the machine, but we always advise that the places where the challenge with the power stability, you can always use the stabilizer, and that will help you. We have some of the country in our country where that will solve by adding the stabilizer, and then the power for the machine. So another question which is also very common is the concentrator not turning on. So which is also to be the power issue. Maybe if you have someone with experience, you can try on this one, or someone who has encountered this challenge. Can you please share your experience? Most of the time, I think this also could be. So when the concentrator is not turning on, you should also ask yourself, will there be an alarm or not? Because and we all know that if there's a power challenge and the concentrator is not getting power, there are always certain alarm which always come. So most if you have that alarm, most of the time it's a power challenge, so that you can also contact the biomed, then they can, if you have someone on your site, or you can contact us. Yeah, you can always contact someone who is always there to guide you. James the vaporizer, as has been explained in the lecture, always teach once a month, or depending on this one, can even go up to 2-3 months. But always remember to drain your VAP, have your schedule, and always follow it if it's monthly or even 2 months, depending on how busy you are. Next. Is there any question? Any question, please? If you become qualified, please. If there's no any question, I'll hand it back to Magdalena for closing out. Once again, thank you very much. Hope I'll be given another opportunity to present to you in the near future. Max, welcome.
Okay, thank you so much. Richard, you had something to say? Please go ahead.
Yes, please. Thank you so much. I'm actually enjoying the discussion. It's so wonderful, and I think I've been missing it by myself, and now this is an opportunity that I have got to ask this one. This one is especially to the ventilator. This has been a challenge to me whenever I try to switch from the bellows to the ventilator. It usually tells me that the patient is connected already and it doesn't start. So I would like to see if any can help me see how I can get how I can do it better. Thank you so much.
Thank you. Of course, yes. That is not only, it's a very common challenge for most of our users, especially if you don't follow the sequence I explained before. So if you want to go to the vent, what we advise, you set the bell selector switch to the vent, and then you go to the vent, you start with the vent. Because when you start with the vent, and then when the vent starts ventilating, before you switch the isolator switch to the vent, the air will leak through the barrel, and that message will come. So I think what should be done next time, what you do, you start with the barrel isolator switch, send it to the vent, then you go to the vent, and then you start your ventilation. Even when you finish, you start with the vent, you stop ventilating, then you come down, you switch it up, you send the isolator switch to the barrel, then you start ventilating manually. That will always avoid that alarm. I hope that was clear.
Yeah, thank you so much.
Okay, thank you so much. I am really thankful for, I don't know if anyone else has any questions. I just wanted to make a note. Please feel free to reach out to us. I know we sent out this webinar invitation through WhatsApp. But in case you have any training issues at your hospital and you would like us to support you to support you as a hospital in terms of training, in terms of questions that you have pertaining the use of any of our machines, the UAM, the CCV, the ICV, in a clinical way. Please let us know. You can send your questions on the WhatsApp number. I think I will write it on +254. I'll write it on the. I'll write it on the chat, but it is +254 794 764 415, or just go ahead and send an email to customer@gradienthealth.org. Please let your colleagues also know that you can always reach out to us to assist you in whichever way. Please, even if it is getting spare parts or the machine has a problem, please send in your request. You can send it to customers@gradienthealth.org or the number that I've shared, and we will always try to fix you up with where you can either get consumables or where you can access our technical team who can guide you, and also just to prep on the on training. Otherwise, I'd like to really thank you for joining in, and it was quite a long session. So thank you so much for being very patient. Yeah, I don't know if anyone has anything from the panel. Otherwise, it's thank you from me, and see you again soon.
Thank you. Bye-bye.
Bye-bye.
Thank you,
Bye,
everyone.
guys. Thank you.
Okay.